Welcome dear students. In thermodynamics, anything which is under our observation or under our study, that is called as the system. Now the physical and chemical properties of the system can be divided into two categories. One are the intensive properties and second one are the extensive properties. The intensive properties are also called as intensive quantities, and the extensive properties can also be called as the extensive quantities. Now, what does they mean? My dear students, these are two copper wires. This one is the wire with shorter length, and this one is the wire which has greater length. Now, my dear students, can I say that this one is shorter in length because it has lesser quantity of matter in it, and this one is longer in length because it has greater quantity of the matter in it. It means that the length of the wire is something which is dependent on the size of the system, which is dependent on the amount of the matter in the system. So length depends upon the amount of the matter. That will be the extensive property of this system, this wire. So length is an example of the extensive quantity or extensive property, as it depends on the amount of matter in the system. But on the other hand, both these wires, they can conduct electricity. Can I say that this wire is shorter in length, so it will be having lesser electrical conductivity as compared to this wire, which is longer and which will be having more electrical conductivity? We cannot say that, because electrical conductivity is a property which is not related to the amount of matter in the system or the magnitude of the size of the system. Rather, it depends upon the nature of the material of the system. So electrical conductivity of both these wires, that will be same, because the electrical conductivity is related to the nature of the matter, because both these wires are made up of copper. So the electrical conductivity of both these wires, that will be same irrespective of the amount of the matter in each wire. So electrical conductivity of this copper wire, that will be an example of the intensive property. Intensive properties are those properties that do not depend on the size of the magnitude of the system, rather they only depend on the nature of the material which is present in the system. Now let us take another example. My dear students, there is water in these two beakers. This one is a smaller beaker having lesser amount of matter. This one is the larger beaker having greater amount of the matter. We will say, because this beaker has lesser amount of matter, so its mass will also be lesser, and this beaker has larger amount of the matter, water, so the mass of the water will be greater in this beaker. It means the mass is something which is related to the quantity of matter in the system. Lesser the quantity of matter, lesser mass; greater the quantity of matter, greater mass. Similarly, volume is also a property which depends upon the amount of matter in the system. Lesser the amount of matter, lesser volume; greater the amount of matter, greater volume. So mass and volume, these are the two properties that are basically dependent on the amount of the matter in the system. So they will be examples of the extensive properties. Now, if these two beakers are placed under the room conditions, they have different quantity of water in them, but my dear students, the temperature in both these beakers, that will be same, provided that they are present in the room conditions. It means the temperature is a property that is not related to the amount of matter in the system. This one even lesser matter, this one is having greater matter, but the temperature of both, that will be same, provided that they are present under the same conditions. So temperature is a property that does not depend upon the amount of matter in the system, and that will be an example of the intensive property. Now concluding that, we will say that any property of the system which depends on the amount of matter of the system, that is called as extensive property. And any property of the system which is independent of the amount of the matter and it only depends on the nature of the matter in the system, that is called as the intensive property. Now let us look into the examples of the intensive and extensive properties. First of all, we have intensive properties which are independent of the amount of the matter in system. The famous examples are color, taste, hardness. Now this whiteboard is hard. If I will cut a small piece out of this whiteboard, that will be having same hardness as that of the complete whiteboard. It means that the whiteboard is present in a large piece or whether it is present in a small piece, the hardness will remain same. So that is independent of the amount of matter. That will be an example of the intensive property. Similarly, I have just mentioned temperature, pressure, electrical conductivity. I have just explained a few moments before, taking the example of the copper wires. Similarly, viscosity, surface tension, and all those properties of the system with which the word specific is used, like specific rotation or specific heat capacity or specific conductance. So any property of the system with which the word specific is used, they will be under the headings of the intensive properties. They will be the examples of the intensive properties of the system. Similarly, refractive index, the degree of diffraction of the light does not depend upon the quantity of the matter through which the light is passed. So it is also an example of the intensive property. These are some famous examples of the intensive properties. Now let us talk about the examples of the extensive properties. Like I have just given an example of the mass. You can say weight. Similarly, there is an example of the volume. There is example of the standard electrode potential, entropy, enthalpy. Enthalpy is also an example of the extensive property. If you have a small piece of wood, its enthalpy of combustion that will be different. And if you will be having a large piece of the wood, obviously its enthalpy of combustion will be greater. So it depends upon the amount of the matter. Similarly, internal energy, number of moles. So these are some famous examples of the extensive properties. I have just explained another property, that was length. So these are all the examples of the extensive properties. Now, my dear students, sometimes if we take the ratio of the two extensive properties, then it becomes an intensive property. For example, if we take the ratio of mass and volume, you know that the ratio of mass and volume, that is basically equal to density. So mass and volume both are extensive properties, but density is an example of the intensive property. So density is an intensive property. Why? Because density is mass per unit volume. So whenever you are calculating the density, you are taking the mass in unit volume. For example, the density of water is 1 grams per ml. It means whenever we will be calculating the density of water, it will be calculated in 1 ml of the water. And the mass of 1 ml of the water is always 1 gram. So the density will remain same. It does not depend upon whether you are talking about a drop of water or a swimming pool. In both cases, the density of water that will remain same. In both these beakers, the quantity of water is different, but the density of water in this beaker and in this beaker, that is same, that will remain 1 gram per ml. So density is independent of the amount of the substance, because whenever we calculate the density, we take the unit volume, and a mass of a specific substance in unit volume always remains same. So density will be an intensive property. My dear students, there are some properties of the system that cannot be categorized into the intensive or extensive properties, just like the square root of the volume, that will neither be an intensive property nor it will be an extensive property. So basically the intensive properties and extensive properties, these were the two terms which were introduced into physics, and then it were used in the chemistry, and according to the recommendations of the International Union of Pure and Applied Chemistry, these two properties are defined in the way I have just defined them. So it was all about the intensive and extensive properties of the system. If you feel any problem, don't hesitate to ask in the comment section. I will answer that. Take care.